Okay, we're going to spend some more time talking about functions today. We're going to talk about inverses and operations with functions, and we've got a couple of applications as well. We'll start with determine the inverse. So I gave you some steps in the PowerPoint presentation, the summary. If I want to find the inverse of h of x, the first thing I'm going to do is, well, just to make it look a little bit nicer, I rewrite this as y. Just for the time being, I'm going to put it back actually as h inverse of x when I'm done. So, but my steps said solve for y, or x, so I'm going to subtract 4 from both sides. Y minus 4 equals 5x squared. Divide both sides by 5. X squared equals y minus 4 divided by 5. And then take the square root of both sides. X equals the square root of y minus 4 over 5. Okay, once you've solved for x, we actually switch things back because we don't want it to actually say x equals. So we'll say h inverse of x equals the square root of x minus 4 over 5. So then we'll change out x and y. If it makes you feel better, you don't have to do that at the end. You can actually do that at the beginning. So for my second one here, if I rewrite this as y equals 5 minus 8x, if you want to go ahead and flip-flop your x and y, you can. It might make it a little bit easier. And then solve for your new y. So I'm going to subtract 5 from both sides. X minus 5 equals negative 8y. And then divide by negative 8. Y equals x minus 5 divided by negative 8. And that is the inverse, G inverse of x. And yes, notation is important, so I want to make sure you know that notation. Alright, so let's try another one. If I flip-flop my x and my y, I have x equals y plus 2 over 8. And I'm going to solve for y. So if I multiply by 8 on both sides, I have 8x equals y plus 2. And then subtract 2 from both sides. 8x minus 2 equals y. And so that's our inverse of x. 8x minus 2. And then my very last one, y equals 12x, flip-flop x and y, and then solve for the new y by dividing by 12 on both sides. X divided by 12 equals y, and so P inverse of x is x divided by 12. Alright, here we're going to talk about operations with functions. All we're doing, this is f plus h of x, so given two functions, I want to add them together. 3x squared plus 7x minus 9 plus my h of x function, 8x plus 11. Combine like terms, 3x squared plus 15x plus 2. And that's f plus h of x. We can also subtract the two functions. So 3x squared plus 7x minus 9. There's function number 1 minus function number 2. And there's a reason that I put these in parentheses, because I have to remember to distribute that negative. So 3x squared plus 7x minus 9. Once I do that, I can get rid of the parentheses. Minus 8x minus 11. Okay. Combine like terms. 3x squared minus x minus 20. And that's f minus h of x. There are two other operations, multiplication and division. For multiplication, we are going to have to, it will take a little bit of work to get these multiplied. And that's actually a typo. It should say h. I don't have a g of x function. So I'm going to take my 3x squared and multiply it by both things in the other parentheses. So 24x to the third plus 33x squared. Then I'm going to take my 7x and multiply it by both things in the parentheses. So plus 56x squared plus 77x, and then take the negative 9 and multiply it by both things in the parentheses. So minus 72x minus 99. And then combine like terms. So 24x to the third plus 33 and 56 is 89x squared. 77x minus 72 is plus 5x, and then minus 99. And then our last one, you all will like this one the best, is dividing them. And we really, unless there's something obvious that we can cancel out, we really don't have to do anything except write them as a division problem. Okay, this is a picture that was in your PowerPoint summary as well. This is composite functions, f of g of x, which can be written both ways. Basically, we take whatever our x value is and put it into the g of x function, and we get something back out. And then we take that and put it into the f of x function, and we get something back out. And that's the composition of functions. It works the other way too, that I can take an x and input it into the f of x function, and I get some output. Then I take that output and input it into the g of x function, and then I get, again, some final output. So let's try. We have g and h. I want to take my h of x function and put it inside my g of x function. So 7 times, instead of x, I'm going to put this whole function in, 9x plus 5, close parentheses, plus 2. And then distribute. 63x plus 35 plus 2. And so my g of h of x is equal to 63x plus 37. This works the other way too. I can take the g of x function and input it into the h of x function. So 9 times 7x plus 2 plus 5. So 9 times 7 is 63x plus 18 plus 5. So h of g of x is equal to 63x plus 23. And then here's an example where we actually have a number to use, which you all may like even more. I'm going to take 3, the number 3, and put it into the h of x function. And then whatever I get back out will go into the g of x function. So h of 3 is equal to 9 times 3 plus 5. So that's 27 plus 5 is 32. So now I'm going to take this and put it into the g of x function. 7 times 32 plus 2 . 224 plus 2 is 226. And so that is what g of h of 3 is. And then our last one, I'm going to take 3 and put it into the g of x function, and then take the result from there and put it into the h of x function. So 7 times 3 plus 2 is 21 plus 2, 23. Take that and put it into the h of x function. So 9 times 23 plus 5, 207 plus 5 is 212. So h of g of 3 is 212. And then we have a couple of applications. A company's profit is equal to revenue minus cost. So profit is equal to revenue minus cost. The revenue for a certain product, R of n, is 150n, and the cost is 50n plus 200. Determine the profit function. Well, I wrote it up here. Now let's use some actual function, like our actual function. So the profit of n is the revenue, 150n, minus the cost function, 50n plus 200. I'm going to have to distribute that minus. So the profit for n units is equal to 150n minus 50n minus 200. And then combine my like terms, 100n minus 200. So there's my profit function. If we sell 25 units, I'm just going to put 25 in for n. So P of 25 is equal to 2,500 minus 200. So P of 25 is equal to 2,300. And then how many units do you need to sell to break even? So it's asking how many units do you need to sell in order for your profit to be 0? So if I want my profit to be 0, I'm just going to solve for n. So 2, and I will break even. And then the second application, a pebble is dropped into a calm pond, causing ripples in the form of concentric circles. Concentric circles look like a target or a bullseye. I'll do a terrible job drawing them, but they all have the same center. The radius in feet of the outer ripple is given by r of t, which is equal to 0.6 t, where t is the time in seconds after the pebble strikes the water. And then the area is given by this function that jumped out of place for some reason. It's supposed to be up there. So find the radius of the circle after 2 seconds. So r of 2 is equal to 0.6 times 2, which is equal to 1.2 is my radius. Feet. And then the area of the circle after 2 seconds. Well, once I have the radius, then I'm finding the area of 1.2 feet of a circle with a radius of 1.2 feet. So pi times 1.2 squared is 4.52. Feet squared. And then find a formula for the area as a function of time. That's just a composite function. The area of the radius of time. And so we're going to take our r of t function and substitute it in. So pi times 0.6t squared. And then we would use this formula, and we can plug 2 right in there and be able to get the whole thing done all in one step. Pi times 0.6 times 2 squared. And you'll see we get the same thing. Pi times 0.6 times 2 squared. And we get 4.52.